Welcome back. In this video we'll be building a circuit around the LM386 audio amplifier. It's the simple, almost famous 8-pin dual inline package. It's just the simplest of chips imaginable, but building a circuit around it that actually sounds decent, that's always the challenge, and that's what we'll focus on in this video. There's a lot of videos out there building circuits with the LM386, but it's just been my experience attempting to build a lot of them that they don't sound very good. There's a lot of crackling, popping, radio interference, etc., etc. And I, through just tons of trial and error, have come up with a particular circuit, namely this circuit. I'll zoom out a little bit. That sounds pretty good. It doesn't have any static, no crackles, no pops. The sound exiting the speaker is fairly clear. And at this point, this is about the best circuit I've been able to come up with. I'm sure there's others that can do way better if they're audio engineers or they work in the audio field every day. But for our purposes, we'll walk through building this particular circuit. You can copy the schematic. If you would prefer not to deal with the op-amp configuration with the input and output and all the pins out of order, for those who would rather not have to deal with figuring out which pins go where and how to hook things up, I've created this schematic which goes directly off of a breadboard layout. And we'll be following it as we go along. Zoom out, get the whole thing in the picture. And that's the schematic that we'll be going by during this video. Instead of going through all the parts, I'll just have them in the description below the video. And the first thing you'll need is just a breadboard and an LM386 chip. I have an LM386 N3, which on a good day should put out around 700 milliwatts of power. If you get an LM386 N1, you'll be closer to the 500 milliwatts of power output. I tend to prefer this 700 milliwatts. They do make a LM386 N4, which can put out about a watt. Any of them will do. The more wattage it'll output, or the higher that number, that LM386 N1 will put out less power than an LM386 N4, etc. So, and one final note is you can find these little chips extremely cheaply on eBay or other online vendors, but it's been my experience that you don't want to go cheap on this chip. If you can find one from Fairchild or National Semiconductor, that's the way to go, buying it from a manufacturer like Jamco or Mauser, or a distributor from like Jamco or Mauser, because I have bought cheaper versions of this chip and all the circuitry in the world won't take out the static. So the most you'll pay is $1.50, $2 for the little chip, even if you get a name brand. So it's worth your effort and time. If you want a circuit that'll sound halfway decent, to get one from National, Fairchild, etc. Get a name brand chip. That being said, we need to arrange a power supply for this chip. I'll just be using a 9-volt battery. You can power the chip from 4 volts all the way up to 15, 18 volts. 9 volts works fine. I'm just going to insert the battery clip for a 9-volt battery. Then, to decouple it, when there's power surges, when the amplifier is trying to draw more power, depending on the volume, we'll put a 100 microfarad capacitor across the positive and negative rails. And then for even a little added decoupling, we'll put a 0.1 microfarad capacitor across the power rails, right behind that 100 microfarad capacitor. And notice this 100 microfarad capacitor is polarized. Make sure to put the black stripe toward ground. Then we'll need to connect our ground rails from this ground rail to that one. and that takes care of our power supply for the chip. The next thing we'll need is the audio input side. I have a 10K potentiometer. The breadboard friendly doesn't mean fits perfectly in breadboards. It just means that if you push it in hard enough, it will tend to stay, but sometimes depending on the type of breadboard, it'll want to push itself back out. So just something to keep in mind. And we'll just snap it into the breadboard, but before doing that, it's easier to go ahead and insert the ground line, which will go on this pin of the potentiometer. There's a wire for ground. Then we can put in the potentiometer. Okay. Just a wire from ground to the third pin of the potentiometer. For audio input, I'm going to use a simple audio jack that'll fit into a standard MP3 player. This is a stereo jack. You could use a mono jack. Either one will work. All I've done is, this is going to be a mono amplifier, means it'll amplify one of the lines. There are ways to connect the left and the right stereo together using resistors, but for our purposes, I'm just using the right line from the MP3 player and the ground. To connect it, first the ground line goes into the ground rail of the breadboard. Then the audio input line goes into the first pin of the potentiometer on this side. Wire from the audio jack to the first pin of the potentiometer. And at this point, returning to our schematic, we would have constructed this part of the circuit. The positive audio in goes to the first leg of the potentiometer. The negative of the audio goes to our ground rail. The third leg of the potentiometer goes to ground. Now we're following this line down, and it's going to go to pin 3 of the amplifier. But we'll stop and assemble some other circuitry before we go past this line. But coming off the potentiometer, we need a wire off of the middle pin. Like that. We've got our wire coming from our center pin of our potentiometer. It's outside on a row of the breadboard so we can access it. And then, according to our schematic, so we've just put this wire in. Now we need a 400 picofarad capacitor from this line to ground. So they read as 471 on typical ceramic style capacitor. And we'll need to move this out of the way. Here's our 470 picofarad capacitor from our center line from our potentiometer capacitor, and then we'll need to add a wire into the same row to go to pin 3 of the amplifier chip. But before doing that, it's easier to run some other circuitry. So we'll pause on that particular part of the circuit. Now going to the top of it, from pin 1 and 8, there's a 10 microfarad capacitor. This has to do with the gain of the amplifier. You can look at the data sheet, but if you put a 10 microfarad capacitor in this orientation from pins 8 to 1, you'll get the maximal gain out of your amplifier. And it's a gain of around 200. We have a electrolytic 10 microfarad capacitor. Paying attention to the orientation is that the positive side of this capacitor should go toward pin 1, the negative side should go toward pin 8. That's your negative side. Here's pin 1, pin 8. We just insert electrolytic in there so that everyone can see from pin 1 to pin 8. Next, we can go to pin 7, which is the bypass pin, and we have a 10K resistor connected to a 10 microfarad capacitor that tracks over to ground. So 10K, a 10 microfarad capacitor with the polarization where the positive side is toward that 10K resistor, the negative side of it is toward ground. $10K resistor. Here's pin 7 directly below pin 8 on the chip. There's 10K. It's one leg is in the rail above pins 1 and 8 into pin 7 of the chip. So pin 7. Now we need our 10 microfarad capacitor with the positive side going toward the 10K resistor, the negative side going toward the ground rail. So the 10K resistor, the positive side of the electrolytic of the 10 microfarad, and then there's the negative legs running in this rail. So we'll need a wire from this rail over to our negative rail of our breadboard. Like that. From the negative side of that 10K, this is the bypass pin. It just, any noise that has been amplified in the line coming on the audio signal, this helps to reduce that noise. That's what the bypass does. Through there. That takes care of pins 1 through 8 and pin 7 through here to ground. Moving down, we can notice that from pins 6 through 4, there's a 1 microfarad capacitor decoupling those two, and this is important. It'll help reduce the noise in the power supply and right at the chip. And anytime you're working with an audio amplifier chip, you want to get everything as close as possible to the chip, have the shortest leads you can accomplish. And so pin 6 goes to VCC, or our positive rail, then it's decoupled to pin 4 via a 1 microfarad capacitor. 1 microfarad polyester capacitor. Polyester just tends to sound a little better. There's pin 6, pin 4. So we decouple across the chip. It's a little hard to see, but that's all there is to it. Here's pin 4 of the chip. We've got our 1 microfarad capacitor decoupling to pin 6 of the chip on the other side. This is just inserted across the top of the chip, and now we need a piece of wire from pin 6 over to our positive rail. Like that. We can continue moving right along. Pin 2 is the inverting input to the op amp inside the LM386, and it goes to ground. We just need a piece of wire, and here is pin 2 of the chip on that rail. We just have a piece of wire from pin 2 to the ground rail. At this point we can complete the audio in part of our circuit. That, recall, we have our positive audio in going to the pin 1 of the potentiometer. We have the potentiometer 10K. The third leg is going to ground. We have a piece of wire coming from that center pin being decoupled. This eliminates radio interference. You can put this in and pull it out while it's running, while you're not feeding audio input to it, and you just have the circuit powered, and you'll hear radio noise just from the atmosphere. Then you can put that one little bitty decoupled capacitor in there, and it will pull, or this is a filter capacitor in this context, and it will eliminate 90% to 99% of your radio noise and interference. It's a very important little capacitor. This is the value that I found through trial and error, experimenting with it. I got the best cancellation of radio frequencies with this particular value. You may need to use a smaller value or a slightly bigger value. You can pull it in, pull it out, and see which one cuts the most radio interference when you have the circuit powered. You have power going to the LM386, but you're not feeding an audio signal through it. That's when you'll hear the radio interference. And just experiment with this value and see what you get. We already have it in. Now we need this wire to pin 3 of our LM386. Here's the center pin of our potentiometer, the wire, the filter capacitor, that 470 picofarad. We'll insert a wire here to pin 3 of the LM386. Like that. There's the wire from the center pin of the potentiometer. The radio interference is cut with this capacitor, and then it goes over to pin 3 of the LM386. We've almost completed the circuit. We've taken care of pin 8, 7, 6 with the decoupled capacitor. Going to pin 4, we have pin 4 to ground. We have our non-inverting input from our audio in, positive audio in. We just completed that circuit. We've got ground to pin 2. We've got our bypass capacitor resistor network. Now we can move forward. We need a wire coming off of pin 5. There's pin 5, it's bottom pin. We need a piece of wire. Here's just a piece of wire coming off of pin 5. Now, according to the schematic, we'll need a 10 ohm resistor and then a 0.1 microfarad capacitor going all the way to ground. Our 10 ohm resistor, in the same row as our wire. 10 microfarad capacitors, polyester. You could use ceramic, it'll just sound a little better with polyester. This is a last ditch effort at filtering. We have our 10 ohm resistor, our 0.1 microfarad capacitor going to the ground rail. Then we need just a piece of extension wire to extend things a little further out. And so we just took care of this resistor capacitor network on the output line. Then you can use anywhere from a 220 to a 1000 or even larger microfarad capacitor. I've found that a 1000 sounds a little better, it outputs a little cleaner sound, but experiment with these capacitor values and see what sounds better to you. You can experiment with any of these values. This decouple from pin 6 to 4 needs to be a 1 microfarad capacitor, but you can experiment with the values of this last ditch effort of noise removal if you want to. See what sounds better. To me, this sounds as good as I can make it. And so now we need our 1000 microfarad capacitor. Noticing the polarity, the negative side of this electrolytic will go toward the speaker. It's an 8 ohm speaker. The positive side will go back toward pin 5. 1000 microfarad capacitor. The negative side goes toward the speaker where we're going to plug it in. The positive is back toward pin 5. And we'll just plug the legs in. Bottom rail, and this bottom rail is where our speaker should be connected. We can zoom out, and I just have a Spark Fun box with an 8 ohm speaker. It's a 1 watt, 8 ohm, 8 ohm 1 watt speaker with its wires coming out of the back of the box. This just enables me to keep the speaker somewhat vertically aligned. Now, all we need to do is our positive line from our speaker goes into this rail, the negative leg of the electrolytic, and then the negative line of our speaker goes into the negative rail of our breadboard. There are, of course, other ways to have routed the grounds and all sorts of various things one can do. And also, something that I just noted is almost forgot to actually connect. Here's pin 4 of the chip. It needs a wire from pin 4 to the ground. Sorry about that. And the completed circuit will look something like this once you're done. Here's your audio in, going through the potentiometer to the chip. And I'll show the schematic at the end of the video, but we can zoom out and see what this sounds like. At this point, I've connected the 9-volt battery to our circuit. I've plugged in an MP3 player, and we should be able, and I've turned it on. And note that with these audio amplifier circuits, you should always connect your power to the amplifier before you turn the power of your MP3 player on. And let's see what it sounds like. Another song. Some Bach. If it was going to distort, it would have distorted right then if it was going to. One last song. I'm just using the MP3 player to adjust the volume, but you could use this potentiometer. You can turn it left or right to increase or decrease the volume. The way I have it wired, if you turn it right, the volume is decreased, resistance is increasing inside the potentiometer. You can turn it left to increase the volume, whichever you prefer, either from your MP3 player volume adjustment or the potentiometer. And note that this setup is obviously not going to sound the best. The enclosure is not the right size. This is not the greatest of speakers. This is just a 3-inch, 8-ohm, 1-watt speaker. But you can experiment with larger speakers. Normally, the larger the speaker, the better it's going to sound, but you don't want to go too large either. But you would rather that your amplifier run out of power than you had your speaker not be able to handle enough wattage. This is only putting out anywhere from 500 to 700 milliwatts, so you're not really in much danger of damaging any speaker 1 watt or above. You're really in no danger of damaging such. As long as you're wiring the circuit, there's not a whole lot of interference. If you've wired it up along these lines, it shouldn't snap, crackle, pop, all those various nasty sounding things that come out with analog circuitry. I hope this video has been helpful. If you liked it, please click like and consider subscribing to my channel. Thank you. But one thing before exiting, I said I'd display the schematic one more time. This is the schematic we followed. Do this out of the way. There's the schematic and then the hookup guide. We have the 10K. We can start at pin 1. The gain is set by a 10 microfarad capacitor. Notice the polarity across pins 1 and 8. Pin 2 is connected directly to ground. Pin 3, the positive audio enters on the pin 1 of the potentiometer. Pin 3 of it's grounded. The audio ground is connected to breadboard ground rail. There's the center pin of the potentiometer. It is filtered through this 400 picofarad capacitor. This cuts the RF frequencies that normally appear when you use an LM386. It continues this wire down to pin 3 on the non-inverting input. Pin 4 is decoupled via this 1 microfarad capacitor to pin 6. Pin 6 is connected to VCC, your 5 to 9 to 10 to 12 volts. Then pin 4 from there is connected to ground. You have the bypass hooked up through a 10K resistor, 10 microfarad capacitor to ground. That's pin 7. Then the output on pin 5. One last ditch effort at filtering any noise that was amplified through the amplifier. And our circuitry is a 10 ohm resistor, a 1 microfarad capacitor. It keeps running. I used 1,000 microfarad capacitor because that's what sounded the best to me after experimenting, but you can experiment with values anywhere from 220 microfarads all the way up to 1,000 to even 2,000. Just experiment with it, see what sounds the best to you. That terminates at the positive line to our 8 ohm speaker. The negative line of our 8 ohm speaker is connected to ground. The main thing you want to watch out for with your grounds when you're building an audio amplifier circuit is you want your input grounds, like this is an input circuitry, this bypass, the non-inverting input, that's definitely input circuitry. And these are all audio input circuitry. You want them to be oriented, as far as the breadboard goes, you want those tapping into the ground rail before this negative line of the speaker. You don't want the negative line of the speaker junking up the ground rail voltage. So you connect it last to the very bottom of the ground rail, and that gives you some isolation between your input grounds and your output grounds. There's other ways you can wire it. There's some videos on YouTube about getting your ground rail straight with this LM386, and those are important. They're worth watching. But using this setup, you should have an LM386 chip that sounds fairly decent. Sounds good to me, at least, and that's a challenge. It's not easy to get this little chip. It's a great little chip, but it takes a lot of passive components to make it sound right. But there's the breadboard circuit. And here is, for those who would prefer the actual audio amp pins scrambled up circuit, there's the same circuit. There's a 220 microfarad on the output line to a 1000, but it's the exact same circuit. Now, I hope this video has been helpful. If you liked it, please consider clicking like and subscribing to my channel. Thank you.